Hi everyone, today I'm going to walk you through my final apply project and my final research paper through this presentation. So my project's based on an online food ordering system for specifically sit-down restaurants. So let me start with the presentation. Um, so the scope of my project, as I already mentioned, is to basically create an online ordering system for sit-down restaurants where the system can take advantage of the customer's mobile device. Most customers or most people nowadays have a mobile device that has a integrated camera. So with that mobile device, they can scan a QR code that's going to take them to the restaurant's menu where they can start ordering food immediately. So the overall description of the system, it tracks the calories that you order through the application. It also displays the amount for the check, and it gets updated on real time. So as soon as you order something, it will show you what you the amount due, and if you order something more, it's going to update that amount. It shows pictures of the menu items, and it also allows customers to cancel orders, and I'll be showing you that later on this presentation. So the technical description, the application was built using HTML, PHP, CSS, and PHP My this framework consists of all of free tools. They're all free, so it didn't incur in any costs or anything. It also works in any operating system, so iOS, Android, macOS, Windows. And it also works in any device, so tablets, phones, even computers, which would be weird for someone to take a computer to a restaurant, but if they wanted to, it would work. And there's no need to download an application or anything because it's an online web page, so it's pretty simple for the user. So the product perspective, most food ordering systems nowadays uh, offer only a delivery service, so you can order from home, but and there's some for pickup, but not there's not like a system that's widely known for like um, sit down restaurants or for in house dining. Um, so this solution basically what's trying to propose is just to speed up the process of ordering once you're sitting down at a table in a restaurant. There's also no need to log in or create an account or waste time doing all of that and trying to remember passwords and any of the, or any of that. So that's a big advantage of the application. So let me show you a demo because I think that's the best way you can understand what or how the system works. So before I scan the QR code, let me take you to my phone. So in the screen you can see my phone. Let me unlock my phone. Okay, so the easiest way to access the application is just to go to your camera. Most phones already automatically scan QR codes. So if you go to the QR code, you can see that it already popped up the site. So you just click there, and it's going to immediately take you to the menu of the restaurant you're at. At this point, the system already knows in which table you're located because of the QR code that you scanned. This menu is really simple, so for the demo purposes, I just added 2 items, but you can add as many items as you want. Once you're in the menu, you can um, press the box to add the number of items, and it will show you a nice trackpad with digits. So it's pretty easy to say I want 2 orders of wings because I'm really hungry, and I also want a cheeseburger because I'm extremely hungry. So once you're done, you can click done. You can submit the order. You can see that the calories got updated and the price got updated immediately. You can see what you've ordered. Uh, let's say I'm still hungry after all that food and I want some more wings. I can add an extra order or have friends coming so I can add another order. Again, the calories and the price immediately got updated. The new wings or the new order got added to the list. Um, let's say again I want to order something or by mistake I thought an extra friend was coming or something like that, and I order, I can cancel that order. For the demo purposes, that button disables after a couple of seconds, but in real life we can set it up to get disabled after, I don't know, 5 minutes. Normally within the first 5 minutes, the kitchen hasn't started cooking your food. So let me show you that again. So let's say I wanted like one set of wings. See the cancel order, it will disable in a couple of minutes. See, now it's disabled, so you cannot cancel the order. So that allows customers to, um, get the chance to cancel the order at least in the first couple of seconds. But like I said, that could be set up, modified to however many seconds or minutes the restaurant wants that set up. You can also see that this is a screen where the kitchen staff's going to see the incoming orders. You can see the incoming orders here. You can see the cheeseburger, the wings. You can see which table's ordering that. So in this case, that QR code that we scanned was for table number 2. So that's why it says table number 2. We can see that the order got canceled here too. But now let's say another customer comes from and sits down in a different table. So again, they can go to the camera, scan that code. I believe this is going to be table number 3. It's going to take them to the menu. And let's say this new customer is going to order, it's going to order a set of wings. Submit. Nope, that's not the right QR code. So let me go to the different one. I believe this is the right QR code. One sec. So take the photo. That should be table number 3. So hit submit. Yes. So that's table number 3. Now table number 3 is also ordering, so the kitchen staff can see all the incoming orders, but they know which table is ordering what. Same functionality for all tables, of course. You can see at table 3 ordered 3 wings. Let's say that was a mistake. So they cancel those. They should see the cancellation coming through. So they submit it. They cancel the order. There you go. It's canceled. I guess I didn't cancel the other one on time. But now you can see table 3 cancel that order. Yeah, the cheeseburger and the wings were not canceled. That's why they're here for table 3 and 3. So once the customer is ready to request a check, they can simply request a check, and it's going to say thank you. Again, the kitchen staff is going to get a notification saying that table number 3 has requested the check, at which point, the waiter can just simply take the check to them and they can go through the normal payment process. I also want to mention that in case that for some reason the user does not know that the camera can scan QR codes, they can simply go to the web page. So in this case, my webpage, it's fruit.epsi.com. It's a free hosting service that I'm using right now. And it will take you to the landing page where it has a button that says choose file. When they click on that one or tap on it, it's going to bring their camera and they can simply take a picture of the QR code, then click on or tap on use photo, and that's going to load the menu. So there's different ways of getting to the menu. The easiest one, like I mentioned, is going to your camera app, but if that doesn't work, you can go to the main web page and it's going to open it for you because the code has a QR code reader too. So overall, that's the demo of my application. Like you saw, it really speeds up the process of ordering food. Like within seconds, you're gonna have your order ready, and the kitchen's gonna get the order within seconds. So we saw the demo. So what's my hypothesis for this project? Basically, I'm trying to prove that sit-down restaurants can eliminate the table wait times by using the system that allows customers to order food through their phone by simply scanning a QR code, which we already saw how the process works. So my hypothesis is saying that I can eliminate table wait times. So when you go to a restaurant and you go to the host and then you tell him that you want a table for 2, for 3, a lot of times the host will be, okay, it's going to be a 15-minute wait, a 20-minute wait, even an hour wait. So I'm trying to eliminate that wait time by using this application that's going to speed up the process. So in theory, customers are going to get their food faster, leaving the restaurant faster. So there's going to be more tables available. So that's what I'm trying to prove through my hypothesis. So the problem statement. So what's the problem with restaurants? The restaurant industry has really fallen behind, especially when it comes to restaurants where you have to dine in or sit at a table. Um, Nothing has really changed for decades and decades. The system or the process has always been the same. You arrive to the restaurant. Sometimes you'll check in with a host. He'll either tell you there's a table available or that you have to wait. Then you'll sit down. Then you're gonna wait for a little bit till a waiter comes with the menus. Um, you're gonna look through the menu. Once you're ready, you're gonna have to wait again till the waiter comes back to your table. A lot of people don't feel comfortable calling the waiter. They feel that's rude. So a lot of people just simply wait there till the waiter comes back, and sometimes that process can take forever, um, even though they're ready to order. But so it's a really long process, and it's it's the same process. Um, it's the same process that we've had for decades. Nothing has really changed. Um, and no one has really like said, hey, you know what? Why can't we use some type of technology or something to speed up this process? We have so much technology available nowadays that um, someone should try to offer like a low cost, efficient way to speed up this process. So that's the main problem. So the purpose of this research, like I mentioned, is to prove that wait times can be eliminated using my application. And by doing that, it's going to improve the customer satisfaction. I mean, who wouldn't like going to a restaurant and not having to wait, especially if it's one of your favorite restaurants? Um, and also, the use of the application basically enhances your whole dining experience. Gives you information about your calories. You can see pictures, and it's nice just to order through your phone. Also, now with COVID-19 going on, it's cleaner than touching menus that you don't know who has touched those menus. I know your phone's not the cleanest item that can be, but at least it's only been touched by you mostly. So that's also nice. So the research focused on finding data that contains table waiting times so that I can prove that this table waiting times can be eliminated. But in order to do that, I need to find data that shows me, okay, X restaurant has, X minutes of waiting time on their peak time. Um, and then once I get this data, I have to analyze it to be able to prove that I can actually reduce this waiting time with the application. So it has to be some analysis of that data in order for me to prove that. So the data needed, like I said, I need waiting times for restaurants. So Google and Yelp were the sites where I found this data. I mean, Google has been collecting this data. When you go to a location, if it's allowed by your settings, it's going to tell Google that you're there, and they have an algorithm that basically calculates the waiting time for restaurants. And Yelp has it has a system that actually incorporates into the restaurant, so that they actually type how many customers are there, how many are waiting, and it calculates waiting time, so it's even more accurate than Google's. Um, and also need to prove, okay, how much time is actually wasted by waiters performing activities that slow down the customer attention. So I need to find out like the time between someone sitting at a table until the point that order or the order for that person gets delivered to the kitchen staff, because basically that span of time can be eliminated by using my application. So I need to find all that data. I just want to mention that due to the spread of COVID-19, I had to simulate all of these scenarios at home. All restaurants were closed, so there was no way for me to go to an actual restaurant and take recordings because they were pretty much closed when I was performing this research, and that's mostly why I looked for online sources like Google and Yelp to provide me with that data because they've been collecting it for years, so they have pretty good averages. So my research method, basically, I'm just performing a quantitative data collection analysis. Like I mentioned, I'm analyzing data collected from Google and Yelp and from an experiment that I performed that I'll be explaining in a couple of slides. Um, as part of the research, I picked 6 random restaurants from Omaha, Nebraska, some of the most popular ones. So I picked 6 from Google, 6 from Yelp. I picked some of the most popular ones because I knew they were going to have waiting times. And basically, what I did was I looked through all the days of the week and I picked the day of the week that had the highest waiting time for a table because I wanted to prove that I can eliminate the highest waiting time, or at least some of the most peak times. So that's why I recorded the max wait time. I didn't care about when I don't know, a Tuesday morning when there wasn't any wait times. I was more concerned about Fridays, Saturdays, whenever they had the longest waiting time. And then I also performed an experiment to try to come out with time recordings of how much time was wasted by, and not, I want to not say, maybe the word wasted is not the correct word, but it's time that waiters had to go around the restaurant, maybe cleaning, taking care of other customers. So all those activities that would basically slow down the waiter or slow down the process of the waiter getting the actual order from a client that's already sat at a table and is ready to order. And don't worry, I'll show a graph or a timeline that shows the whole process that will better explain this. But before I do that, I want to show you some of the rules that I followed for my experiment. These are assumptions, so they're important that they're stated. And remember, this was a simulation that I simulated at home. I'll show you where I simulated that in a little bit. But these are the rules that I followed for that experiment. So for the experiment, there was only 15 tables. So it was a medium-sized restaurant. It was assumed that at the beginning of the restaurant, there was customers were already sat at all 15 tables to simulate that the restaurant was at full capacity. And then before taking any orders, me, that was the waiter, I had to go to every single table and deliver a food menu. So, again, that's time that could be avoided by using my application. But it's like the waiter has to go pick up the menu, go deliver it to the table, then go walk around, take another menu, deliver it to the other table, and so on. It was also assumed that all tables were ready to order at the same time. So the waiter had to go around all tables to get the orders. I used a random number generator to basically define which table I was going to walk to next, and I just generated random numbers from 1 to 15. If a number came out of a table for which I had already collected the order, I would just generate another number till it was a table that I hadn't had an order for. At each table, I spent 3 minutes writing down orders. So normally when waiters go to a table, they have to go one by one of all the people that are sat on that table asking for the orders. Again, my application, you can simultaneously order food all at the same time. So all this time is avoided using my application. So look, even a group of 12, they could all order at the same time. Imagine a waiter having to go one by one. So what's your order? I want a hamburger and this and that. Then to the next one, to the next one. It's a lot of time. And then after every order was taken, I would walk to the spot that I designed as the kitchen to basically deliver the little paper with the order for each table. So again, it's a lot of time wasted just walking to the kitchen to deliver the order. At which, at the point that I arrived to the kitchen, that's when I stopped the recording for that specific table, or the time recording. So each table had a time recording from the moment that they sat down till the moment that the kitchen staff received their order. And you'll see the recordings in a couple of slides. This is just a picture of my community home patio. That's where I simulated the 15 tables. Um, I basically divided the whole space into 15 different little spots where each table was located, and I walked around, taking or simulating that I was taking orders. So the data analysis, and this is the picture that I was talking about earlier. I really want you to pay attention to this picture because it really explains like the whole process. So this is the regular process of dining in a restaurant. A customer checks in at the entrance, then a customer gets seated, and see this little rectangle or green rectangle. This is what I'm proposing, the time that can be saved by using my application. So the point that the customer receives the menu with my application, you can immediately look at the menu. You don't have to wait for the waiter to come with the menu. Once you're ready, again, you don't have to wait for someone to come take your order. You can immediately order, so you're saving all this time. Um, say, so once the waiter comes, again, you're skipping all that process, and sometimes the waiter won't even immediately take your order to the kitchen. They'll probably walk around, clean something. Again, you're saving all that time because as soon as the customer sits down at the table, as soon as they're ready, they can send the order to the kitchen, avoiding or skipping this whole process over here. And of course, after that, it's the same. Once the food's ready, you still have to wait for the waiter to bring it to you. And, the application is not going to reduce the amount of time you take eating. But this, again, this whole time that's surrounded by the green rectangle, that's what I'm proposing that can be um, skipped. So saving all that time. So again, for my research project, I was trying to find recordings of, okay, how long is normally this time? So that's how I simulated the um, 15 table restaurant, and I took recordings of the 15 tables from the point that they sat down to the point that the order got received by the kitchen staff, because all that time is going to be eliminated by my application. So by taking those recordings, if it takes me, let's say it normally would take me an hour to go from this point to this point, but let's say this whole process took, I don't know, 20 minutes. So instead of an hour, it's going to take me 40 minutes because I skipped this whole time over here. So that's what I was trying to prove with my application. So before I start with my analysis, I wanted to find these two terms that I use throughout my paper. Table wait time. This refers to the time elapsed from the point a customer checks in with one of the restaurant hosts up to the point that same customer is seated at a table. So basically, this whole process over here. And then incoming order. This refers to the time elapsed from the point a customer sits at a table up to the moment the kitchen staff receives the order. This is the time encompassed by the green dotted line and the timeline above, or that I showed you. So the incoming order time is this one, which that's what I'm trying to eliminate by the use of my application. So let me show you the data that I collected. It wouldn't. I made a Word document because it looks more. It's easier to present it that way than in a PowerPoint. So here's a table. These are the names of the restaurants that I picked. They're all in Omaha, Nebraska. So this one had a 15-minute wait time. You can see it here. Had a 15-minute wait time. This one again, 15 minutes. Sullivan Steakhouse, Solid Meal, 30 minutes. You can see it here at 6 p.m. It was the longest wait time. Jam Salt Market at 7 p.m. It had a 15-minute wait time on a Saturday. Sunday this one. So as you can see it, common sense. Weekends probably most of the times the busiest times. Tap House, 15 minutes. Rail Car, Modern American Kitchen, 30 minutes on Sunday at 11 a.m. So that's the data that I collected from Google. So those are the 6 restaurants that I collected from Google. Then Yelp, similar functionality. I picked Early Bird, 40 minutes. Mangia Italiana, it had a 5-minute wait time. First Watch Center, we have a couple of First Watch here, so they different locations. That's why it says Center Maple. 10 minutes, 15 minutes. Buffalo Wings and Rings, 15 minutes. Carlos O'Kelly Mexican Cafe, 15 minutes. So that's the data I collected for the waiting times. So now that I had collected the data for the waiting times, I had to come out with the average of, okay, what's the average wait time among all of those restaurants that I collected. So if we do the math, it's going to equate to 18 minutes and 19.8 seconds. That's the average wait time for all those 12 restaurants. So, pretty easy to explain. On average, if you go to any of those restaurants, you'll probably be waiting around 18 minutes. Okay, so now that I have the average, I'm gonna, compare those wait times to the recordings of my experiment. So first of all, let me show you the time recordings for my experiment. Again, the incoming order time, remember, is that space or the span of time that's encompassed by that green dotted rectangle in that picture. So for table 3, this is saying that from the moment they sat down until the moment that the kitchen staff received their order, it was 13 minutes. It's a long time. For table 1, 17 minutes. Again, you have to keep in mind that for this experiment, the restaurant was at full capacity. So imagine going to a game, I don't know, a restaurant, maybe, I don't know, Super Bowl, or, an event where the restaurant is simply full. Table 14, 21 minutes, and so on until, table 9 took 1 hour to take the order. That's crazy. It's a lot of time. But, I've been to restaurants where they're just so busy that it just takes forever. Table 8, now we're in 6 minutes. So now that you've seen the time recordings for my experiment, what I did is now I need to compare those time recordings to the average wait time. So remember, the average wait time was 18 minutes, 19.8 seconds. So what I did is okay, are any of this incoming order times longer than that? Yes. This one, starting from this one, they're all longer. I set them by size, or by smallest to longest. So yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That means that there's at least 13 spots or tables that I could have freed up for 13 new potential customers without having to wait those 18 minutes, and just by using the application. So 13 new tables, it's a lot of more customers that you can accept at your restaurant. It's also going to make customers happy that they don't have to wait. And then I did the same analysis, but this time with the longest wait time for the restaurants. So the longest wait time for a restaurant over there was 40 minutes. Let me go back. I'm sorry for the scrolling. I believe it belonged to Early Bird. It's a really popular breakfast place here in Omaha. Yes. So whenever you go there, you're gonna have to wait in line for a long time. So I was also trying to prove, I said, well, okay, I know I can now eliminate the average wait time, but what about the longest wait time for the restaurants that I collected wait times for? And guess what? Yes, there's at least 1, 2, 3, 4, 5, 6, 7, 8 tables that I could have freed up for potential new customers. So 8 potential new customers wouldn't have to wait the 40-minute wait time. I bet you it's going to make them happy, especially if it's one of your favorite restaurants. It's also going to generate more income for your establishment and going to make your customer happy. So those are the tables showing the data. So pretty interesting. I was not expecting my application to save that amount of, or so much time. But honestly, when you think about it, when you add up all those little times that are just wasted because you cannot not order, you're just waiting on your waiter because he's probably either cleaning, he's probably either taking care of other customers, just doing other stuff, it's a lot of time that gets saved. So I just showed you the table for the longest time too. Um, Besides that, I also was trying to find something that would also add more value to my application. I found this data set on Kaggle.com that contains information about restaurants in the Metro Manila area. It's in the Philippines. Um, so after analyzing some of the data in the data set, and let me show you a quick snapshot of the data set. It had a lot of information like type of cuisine, currency, URL, has delivery, has booking, but I was really focused on this. Is book form web view, so if you could like book a table on online so that you wouldn't have to wait once you get there. Um, and my findings were, at least in the Philippines or in this Manila area, 6,829 restaurants in the data set. Out of that was the total. Out of that total, only 778 had table reservation, meaning there's a huge number of restaurants which you could potentially go and have to wait for a table because there's no way for you to make a online reservation. So this means only 11.39% has a system that supports table reservations, making the other 88.61% perfect candidates to use my system. If I was marketing my system, I would go to that 88% and show them the advantages, show them my research, and try to incorporate my system into the restaurants. So this data set just helps me add value to my application and also like determine which restaurants I could target. So quick discussion about my research. So even though Google and Yelp can provide really accurate data, they've been collecting it for years. They're great at what they do. Um, they seem to round all their times to the nearest multiple of 5. So it was always 5 minutes, 10 minutes, 15, 20, 25. So it would just be interesting to do it with exact timings. I don't know, instead of 5, if it was, I don't know, the waiting time's actually 3 minutes and 45 seconds. Do my analysis with exact timings. I mean, I'm pretty sure the results wouldn't be that much different, but it would just be interesting to have more precise um, data. Another thing, yes, the COVID-19 uh, virus posed a really big challenge for my research. Like I mentioned, all restaurants were closed. It was just hard. I couldn't even leave the house pretty much. So it posed a big challenge, especially when I was trying to analyze data from restaurants that are always full of people. So it was hard, but thanks technology, Google, Kaggle, I found ways around it, and I think I did a pretty good job given the circumstances. And yes, I would like to repeat this analysis or this research once business start opening back again. I know it's going to be a while, and yeah, things are going to be different for a while, but it would be nice to just get real timings, maybe at least from one restaurant once business opened back up again. I'm sure the results wouldn't be that much different, but it would just be interesting. So next steps for my research, this application has endless opportunities, endless features that could be added. But some of the most important, or some of the ideas that I came up with, are that I could include a payment service that could be incorporated into the system, so that way you could just pay and leave without again having to wait for the waiter to come with your check once you press that ready to check out. I also wanted to add like the notes functionality. So let's say you go to a restaurant and you want your fries extra crispy. When you order your fries, it would be nice to be able to add a note saying like, please, I want my fries extra crispy. So the kitchen staff would get that note, and they could cook your fries extra crispy. Um, and also, I want to try to find a way to generate a dynamic QR code, just because I don't want, I wouldn't want people like taking pictures of the code and then going home and then scanning the code again and ordering when they're actually not in the establishment. So I think a solution for that would be generating a QR code. So unless you have the most uh, actual code that keeps generating every so often, you wouldn't be able to order. It will just be an invalid code. But so those are some of the next steps. Like I said, there's infinite possibilities for this application. So as a summary, again, um, my application has the potential to eliminate table waiting times for up to 13 new customers. This was when doing the analysis for the average wait time, which was like around 18 minutes. It also has the potential to eliminate table waiting times for up to 8 new customers for the analysis of the longest wait times, which was 40 minutes. So this just proves the value of the application, proves how much um, faster the dining process can be, and it's not actually rushing you into eating faster or anything. It's just eliminating those wait times before you get your food that are so tedious and take forever. It's just making it faster. Sit down, order, get your food as soon as it cooked, and then you're free to stay if you want, but you're also free to leave if you want. So overall, that's my presentation. Thank you guys.